Hello, geometry classes. Well, we are working now through our lessons dealing with our circumferences of our circles, our areas of our circles, the areas of our sectors, the length of our arcs. So let's see, on this lesson, we're going to start with some theorems to help us answer some of those questions. The first theorem you're probably pretty familiar with. So the area of a circle can be found by multiplying pi times the radius squared, and that's probably a formula you've seen previously. So we're going to use that again today as we answer some questions about circles. The next theorem is similar to the theorem detailing the area of a circle, but this time instead of finding the area of the entire circle, we're going to find the area of a sector. Think of it as a pie piece or a pizza piece, and we're going to find out how much area is in that piece. So for theorem 11.3, I've colored in yellow the sector that we are finding the area for. And just like when we were working with our circumferences and our arcs, we're going to relate the area of the sector to the entire area of the circle. So we're going to go part to whole, just like we did with our last lesson. So to find the area of sector APB, that's the yellow part of the circle here. That's the part. We're going to compare that to the entire area of the circle, which is pi r squared. So part to whole, the part of the circle that we're interested in, the yellow piece in this case, compared to the entire area of the circle will be equal to the measurement of the arc AB, that is the rounded edge of that sector, compared to the entire number of degrees in the circle, 360. So it's still part to whole. The sector area to the circle area, part to whole, is the sector arc length to the entire length of the circumference of the circle, 360 degrees. Okay, so let's see how that works in working out some problems. Example 1, we're finding the area of the circle. Given the information that the radius is 2.5 centimeters, in your book there's a lovely little picture of what's going on here, and I've just drawn the picture of the circle itself so we can see how to work this out. The area of the circle, of course, the formula is pi r squared. We know the radius is 2.5, so we'll plug that in for r. And we happen to know that 25 times 25 is 625 by heart. Placing the decimal point in 625 would be 2 places in, since we have 1 decimal place in each of those 2.5s that we're multiplying together. So without any calculating on a calculator or on paper, we can immediately arrive at 2.5 squared is 6.25. And then use our calculator to multiply pi times 6.25. Now you will see some differences with the values that I'm getting compared to what you might be getting on your calculator. The book is not consistent with whether it's using the pi button on an advanced calculator, such as a graphing calculator, TI-83 or TI-84. That pi button will give you a little more accurate value for pi than just plugging in 3.14. But I know not all of you have calculators that have that pi button, so I'm always plugging in 3.14 for the value of pi, and so these answers will reflect that, so they might be slightly different than what you're seeing in your answer key or in your textbook. As long as they're close, we're good. So we're going to round to the nearest hundredth. That's always our procedure here, and so this rounds to 19.63 centimeters squared for the area of the circle. Okay, next question is asking us to figure out the diameter of the circle knowing its area. Again, we're going to use the area formula. Area is pi r squared. We're going to solve for r. Once we know the radius, r, we're going to double that radius to get our diameter, because the radius and diameter always have the same relationship. R twice is the diameter, half of the diameter is the radius. So here we go. Plugging in 113.1 for the area because we're given that. That's equal to pi r squared. Divide both sides by pi, and that gives us r squared. Take the square root of both sides, and that's going to give us the value of r. In our calculator, we see it's 6.00159, and then we're going to round that off to the nearest hundredth, and that gives us 6.00. Twice that radius is 12.00. Twice the radius is the diameter, so our diameter is 12.00 centimeters. Next problem, guided practice 2, we're finding the area of the red sector. In your book, the other part of the circle is colored in blue, and we can find the area of both sectors, the smaller one, which is red, as well as the rest of the circle, but we're going to focus right now on just what is the area of this red sector. We're going to go part to whole to figure this out. The red area, whatever its answer is, compared to the entire area of the circle, pi r squared, pi times 14, because they told us the radius was 14, so pi times 14 squared, is equal to the number of degrees for this sector, which is 120 degrees, compared to the entire number of degrees in the circle, 360. So it's still part to whole. All right, then we're going to use cross products. The red area times 360 is equal to 100 times pi times 14 squared. Divide both sides by 360, and the red area is 120 times pi times 196 divided by 360. You can plug all of that into your calculator. If there is easy simplifying, I would go ahead and do it. Since 120 and 360 reduced down to 1 over 3, I chose to go ahead and do that simplifying, so 196 pi over 3. Then I used my calculator, and on my calculator I saw the value 205.146 and a bunch of digits after that. I'm going to round that to my nearest hundredth, and that's going to give me 205.15 feet squared for the area of that red sector. All right, guided practice 4. This one's asking us to find the area of the entire circle, knowing the area of the red sector. We're going to go part to whole. The area of the red sector is 214.37 centimeters squared. We're given that information. We're trying to find the area of circle H, so that's my unknown right here. Part to whole, part of the circle to the entire area of the circle is equal to the 85 degrees. That is the measurement for the angle that makes the sector. And then that's going to be over 360 degrees, which is the entire number of degrees in the full circle. It's always part to whole. All right, and then we're going to solve that. Cross products gives us the area of circle H times 85 is equal to 214.37 times 360. Divide both sides by 85, and you have the area of circle H is 214.37 times 360 divided by 85. Use your calculator here, and you will see 907.92 on your display. It's already rounded to the nearest hundredth, so we're done at this point, citing that we are measuring centimeters squared. So we always need to say what we're counting here. We're counting how many square centimeters. This is an area measurement, that's why it's centimeters squared. If it's a length measurement, it would just be the word, such as centimeters or feet. All right, guided practice 5. Guided practice 5 asks us for the area of the half circle and the triangle put together. So this is the information they give us here. I'm noting that the diameter is marked as 7 meters. That means the radius, which I will need to use to figure out my answer, will be half of 7. That's 3.5. To figure out the area of this figure, I have to add together the half circle plus the triangle. Well, the half circle's area will be half of pi r squared, since the area of a circle is pi r squared. The triangle is 1/2 base times height. So now we're going to put the numbers in for our r, our b, and our h and work it out. So the area is equal to 1/2 times pi times our radius, 3.5 squared, plus 1/2 times, well, the base and the height are both 7 on this triangle. It's a right triangle, so we can use the legs for the base and height, and it is 7 times 7 for the base times height. In my calculator, I'll work out 1/2 pi times 3.5 squared and get 9.2325. Half of 7 times 7, half of 49 is 24.5. I'll add those two together, and I will have the answer 43.7325 for the area. I'm going to round that to the nearest hundredth. And my final answer then for the area of that half circle, also known as a semicircle, plus the triangle, will be 43.73 meters squared. And that completes our guided practice problems for this lesson. Please make sure these are in your notes, and it's time to proceed on to the homework problems, and we'll see you next time.